So, hello everybody. In the conference, my name is Donny Wals. I am an iOS engineer and I blog in my spare time. I write books and I do all kinds of awesome things. At least I think they're awesome. I think they're a lot of fun and I really enjoy doing them. I hope you all had fun with the talks so far. By the way, I know I did, and let's get into this one. Before I do, I would like to show you one of my most recent books, or actually my most recent book, and that is Practical Core Data. I'm going to talk about it again at the end of the talk, but it covers core data. It gives you a practical insight into the framework, and it aims to give you sort of a very expansive peek into the world of core data. And it covers both SwiftUI and UIKit. So whether you know SwiftUI or you don't, there should be something useful for you in there. And the purpose is really to teach you the framework more than the UI. And this sort of leads me to the topic for today's talk. And the talk is called Using Core Data in a Modern SwiftUI Application. Now, in iOS, we have core data as our default way to manage and persist our model layer. And core data has been around for a very long time. In fact, it's been around since iOS 3 or macOS 10.4. So that's roughly 10 years ago since Apple first showed us their core data framework. And at the time that Apple introduced core data, we did not have Swift yet. So it was designed completely with Objective-C in mind. And that kind of shows in its API. And Swift did not even, so it was probably just an idea in Chris Ledner's head, or maybe he had just started with it because Swift development did start around that time, but it was most certainly not front and center while designing the APIs. And 2 years ago at WWDC 2019, Apple introduced us to this whole new UI paradigm that we're all learning right now, and that's SwiftUI. And that's been around since iOS 13, and it's been designed to work with Swift, right? Its roots are completely in Swift, and even though it uses UIKit under the hood and it depends on UIKit for everything at this time, at least, or AppKit on the Mac, it hides this as well as it possibly can, and it means that the interface that we program against is just entirely designed and implemented with Swift in mind. We're even seeing that Swift is being developed towards supporting SwiftUI more and more to make sure that SwiftUI is as nice and as beautiful as it can be. Now, this combination of using core data, which is a very old framework, I mean, it's received updates and it's been maintained over the years, but at its core, it's a very old framework. And it has its origins in this Objective-C world. And then we have SwiftUI, which is a very new framework that introduces us for the very first time to a fully Swift-based UI framework. Combining these two leads to very interesting questions. Like, for example, you might be wondering, well, how do I use these two frameworks together? They couldn't be more far apart, right? Objective-C, 10 years old, 10 years ago they started on it, versus, Swift-based, only 2 years old. Like, how do I use these two frameworks in a single application? And which best practices should I use? Or is core data even a good fit for my SwiftUI application? Because obviously there has to be something better. We cannot possibly want to use something this old and something that's so new. Today, I hope to answer some of these questions, and maybe some of these answers that I have are a little bit surprising to you, but they make a lot of sense to me, and I hope I do a good job of explaining why and have them make sense to you too. So let's go over what exactly I will cover in this talk. First, I would like to give you a brief introduction to core data. I'll show you how you can set up a core data stack, and I'll try my best to provide you with a little bit of context regarding what core data is and what it's not. After that, we're going to take a look at SwiftUI plus core data, and mostly we're going to focus on how Apple suggests we do SwiftUI and core data. And of course, I'm going to add a little bit of SwiftUI plus core data according to me. And to be honest, the ideas and thoughts behind a lot of things are roughly the same for what Apple thinks or what Apple seems to think we should do and what I like to do. But I'll just point out the few minor differences as we go. And once I've sort of shown you how you can add core data to a SwiftUI app, we're going to take a look at fetching data in a SwiftUI app, how that works. And then we're going to look at manipulating records. So that's just basically creating a full-blown CRUD application that can create, read, and update, not necessarily delete, records from a store. And I hope to show you that you can do all this without jumping through hoops. And in fact, I don't think I've ever been able to work with core data as smooth and as nicely as I can in SwiftUI. So that's something that I hope to show you. And this is made possible by using managed objects, or multiple managed objects rather. So we're going to talk about that too. And this is a very important and big part of core data because it's not necessarily trivial to work with multiple managed object contexts unless you really know the rules. And the rules are actually not really complicated. It's just mostly hard to follow them all the time because core data's models are not thread safe. And that means that anytime you fetch data from a core data store, you do this into a managed object context. And each managed object context is tied to a queue, or to a thread rather. So that means you cannot just pass everything around. We're going to talk about that a lot more later in the talk. Now, before we move on, I do have a little bit of a disclaimer because I am not here to convince you that core data's design is the very best design in the world. I'm actually also not here to tell you that core data is better than any other persistent solutions like GRDB or Realm. But my goal today is to show you how you can use core data in a SwiftUI application with as little friction as possible. Of course, I'm also going to show you that core data really isn't as bad or complicated as some people might have led you to believe at some point in your career. And I personally actually really like core data as a model layer. It's definitely different than the other model layers that are out there, and definitely different than, for example, GRDB or Realm. And it's most certainly not a SQLite wrapper. I'm going to say that a couple of times throughout the talk, and it sounds a little bit weird, but if you keep in mind that core data is not a SQLite wrapper, it's generally quite nice to work with. All right, moving into the topics of the talk. First, let's do a little bit of an introduction to core data. Now, I'm sure that most of you already know a little bit about core data before you attended this talk. You've probably heard of it, and somebody may have told you that it's clunky, bad, awkward, complex, slow, horrible, old, or slow, or I already said slow actually, or all kinds of horrible things that would make you not want to use it. And maybe you've just heard that and you've avoided core data all your career. And maybe you've worked with core data, but it was horrible for you or it was weird for you. And I hope, if that's the case, that I can sort of show you a better way to use core data that's not as horrible and as awkward that as you might think it is at this point. Because before I continue, I'm genuinely sad that people approach core data with this negative attitude because it's really not that bad. It's really not a terrible framework. Okay, so in the introduction of this talk, I mentioned that core data is not a SQLite wrapper, and officially it's called a graph management framework. And this means that core data does much, much more than just read and write data from and to a persistent store. So let's take a look at a couple of things that core data does for you out of the box. So first, core data performs data validation. So that means that whenever you define your core data model, and I'll show you how to do that in a moment, you can configure several options for your entities and their properties. And you can specify, for example, whether some property is required to be present, or you can say that if you have an integer property, it cannot be larger or smaller than a certain number. You can assign default values to your properties, or you can say that they should not be persisted but only be validated. There's a lot of things that you can do. And some of these things are a little bit weird because, for example, when you mark something as optional in your data model, this means that core data will validate that there's a value present. So that's not necessarily a SQLite feature, that's really a core data feature. And what's a little bit awkward at times is that some of these rules, like optionality, can also be expressed in Swift. But your Swift class and your core data model validation rules are not necessarily the same. So you could have a non-optional property and have it be optional in your core data model, or the other way around, have an optional property on your model, but it has to be set when you want to persist this model. That's something, it's a little bit quirky, it's a little bit weird, but it's really important to keep that in mind, that a Swift class is just a container for the information, and your core data model is the blueprint or the set of rules for your models. In any event, the nice thing is that you can do a lot more than you can with SQLite, because core data does all this extra validation that you wouldn't get in a typical SQLite wrapper. Another thing that core data can do for you is it can maintain your relationships. And in a lot of databases, you'll find that some of your entities are going to have relationships to other entities. For example, you might have an employee record and a certificate record or certifications array of relationships. And this means that your employee has a too one or too many relationship to a certification. And that certification can, of course, be assigned to multiple employees. So it might have a too many relationship to some employees, or it could have a too one relationship to one employee. Of course, depends entirely on your data model. And the way I talk about this relationship is in both ways, right? I say an employee has a certification and a certification has an employee. In SQLite, this is not common. In SQLite, you'll typically specify this relationship on one end. So you could say, my employee has a relationship to a certification, or the other way around. And when you fetch records, you make a join query and everything will be loaded for you. And there's a good reason for this, because if you would set this relationship on both tables or both entities in your store, that would be very error prone, because when you update the employee, you would also have to update the other record and the other way around. And that's why you don't want to have that, because that's going to go wrong eventually. Of course, some ORMs can help you with this, but by default, you'll typically not see this in a simple SQLite wrapper. But with Core Data, you can set up a relationship that has a so-called inverse. And Core Data knows that if you assign a new certification to an employee, that it should also automatically assign that employee to that certification object. So the relationship is automatically maintained and configured in both directions. And of course, there are more features that Core Data does during save and during creation and all that kind of stuff. And that makes it very useful. But something that Core Data also does that you don't typically find in very lightweight SQLite wrappers is data migrations, and more specifically, automatic data migrations. Because for simple changes like adding a property or removing a property, or adding a new entity or renaming an existing entity, establishing relationships, there's a ton of different sort of simply inferable migrations that Core Data can perform for you. So if you would add a new property to an employee, all you need to do is tell Core Data there's a new model version, this is the new model, and Core Data will take it from there. You don't need to do any manual migration work for simple migrations. Of course, if you do a more complicated migration, Core Data needs a little bit of help. So you could specify a mapping model that tells Core Data, hey, to migrate this model to that model, make sure that you map certain properties in a certain way. Or you could even take matters into your own hands and write a custom migration policy where you migrate each individual record by creating an instance of it and changing it as needed. Now, what's nice is that even if you take full control over your migrations, Core Data is still doing this in a somewhat safe way, because Core Data will sort of create a copy of your store and migrate it over, and it will not fully commit to this migration until it knows that everything was migrated successfully. And also keep in mind that migrations are never simple, right? No matter what your data store is, a migration is going to involve some risk of data loss. It's going to be at risk of performing poorly. It's going to be tough. And the main benefit of Core Data versus a SQLite wrapper is that in SQLite, you would typically run a whole bunch of queries or generate a whole bunch of queries that are run against the database. And Core Data hides all of this from you, and you can just tell Core Data to do it, and Core Data will take care of the whole migration of the underlying store. Because Core Data, by the way, I haven't mentioned this, and I keep saying it's not a SQLite wrapper. One of its different persistence options, and also the default persistence option, is to use SQLite. Okay, enough about migrations. It's actually far beyond the scope of what I want to talk about today, but I figured it's a good thing to tell you about, to sort of point out a couple of differences between Core Data and SQLite, or plain SQLite. Okay, so let's talk about setting up Core Data a little bit. And when I talk to people about adding Core Data to an existing project, I typically think it's kind of a big deal, and it's really not that big of a deal. And the easiest way to do it is to add a new file to your project, pick the data model type, and Xcode will create an XC data model file for you. And this data model file is where you configure your Core Data entities and their attributes. So you create new entities, you set up what everything should be, you can configure relationships, and lastly, you can have Xcode generate your managed object subclasses. There are a couple of options here. You can have Xcode generate your whole class, you can have Xcode not generate anything at all, or you can have Xcode generate your model properties into an extension. Another option is to use an export menu to sort of get the subclass into your project. But normally core data will write things to derived data and you won't edit it by hand. I personally like writing my classes by hand, so I typically choose the don't generate anything at all option. But it's you can pick whichever one is best for your app. Now, the reason I like to write my classes manually is because I can do things like use a different data type than Xcode would generate. For example, if I have a string property defined here in my model editor, Xcode would generate this as an optional string on my model. And I know that I can make this a non optional string because Objective-C bridging ensures that there's always going to be an empty string when I access this optional string, even though I didn't set a value, maybe. I'm sure this is an implementation detail that will most likely end up coming back to haunt me. But for now, I'll just celebrate the Objective-C runtime gang because it provides me with some nice conveniences in SwiftUI that I'll show you later in the talk. Okay, now let's look at how Apple adds core data to a SwiftUI project so you can get a sense of what Apple considers good or good enough. Because it's always a little bit hard to tell with Apple whether they consider something to be very good practice or just the best thing they can do right now. Okay, so if you've ever ticked the use core data checkbox in a UIKit application, you know what Xcode does, and you'll also know why I said it's always a little bit hard to tell whether what Apple does is good. Because normally Xcode would add a whole bunch of code to your app delegate, and it would set up everything you need, like a persistent container object, and it will add some conveniences. In SwiftUI, Apple decided to pull the core data stack into its own object, which is much, much nicer. And this is done through a struct called the persistence controller. And they added a static property to it to provide us with a convenience shared instance of this persistent controller. The initializer for this object is fairly simple. If you've not seen core data in a while, it might surprise you that this is how you set up core data now. And the initializer takes a Boolean argument to specify whether it's in memory or not. And having an in-memory store means that it's not persisted to disk. And that's very convenient for SwiftUI previews or for unit testing. And if you've created an in-memory store before, you might be surprised here because we create our core data stack using an in-memory store pointing at dev null. And that is a SQLite store at dev null. And that's the SQLite for create an in-memory store for me. If we would use the normal in-memory store, we would not use SQLite as an underlying persistent mechanism. And we would sort of run into situations where there might be implementations details that are different between the in-memory store and our SQLite store because they're not necessarily all the exact same in the nitty-gritty details. So you want to have everything mirrored as closely as possible if you're going to use this store in tests, for example. Now, I skipped over that preview property that you see here on the slide. So let's take a look at that now. This property sets up an in-memory persistent controller, and it inserts a bunch of objects into the store. And this is very useful for your SwiftUI previews, like I said. But if you decide to use Apple's implementation and use their preview property, keep a few things in mind, because the default implementation uses an item entity, and you probably don't have that entity in your project. So make sure to replace that with setup code that creates dummy versions of your own entities, because your project will not compile otherwise. Now, in a big application, using a single preview property and that sets up like the data store for all of your previews is going to be very painful. So what I kind of like as an idea is to split up your previews into multiple preview properties. Like, for example, I'm showing here on the slide an idea for how I could set up a preview store for my overviews. And you could set up a different store for a detail page, etc. And that will make sure that you don't add a whole bunch of data and don't have like dozens and dozens of lines of code eventually if you have a big data model. And instead, you just set up a temporary store that only contains what you need. Because again, this store only exists in memory, so it's not persisted anywhere. It's literally just in your application's RAM. Or in the case of previews, it's probably in some simulator's RAM memory. Now, overall, I like what Apple's done with this setup. And the only thing I don't like is the preview property. And so what I showed you, splitting it into multiple properties is very useful because that ensures that you keep everything small and manageable. Okay, so once you've set up your persistent container with the core data stack and with everything you need, it's time to use your core data stack in your application. And this is kind of where friction starts, because we have to do this. And when Apple designed SwiftUI, they decided that views can or should have access to a managed object context that is used to fetch data. So they added a managed object context to SwiftUI's environment. And if you want to go for the least friction in your app and use this as Apple intended, uh, just go with it. Roll with the punches and inject a managed object context into your view. It will make your life easier. I'm personally not a huge fan, and I keep going back and forth on my opinion on this. But at the same time, I feel like the more we fight Apple's design choices, the more likely we're going to run into issues down the line. So there is a bit of a trade off here between what's considered good generally in programming and what's considered good within the context of what Apple thinks is good SwiftUI code. Now, I'm not going to go any deeper into like abstracting this during the talk. I'm going to talk about it a little bit, but you can of course write your own abstractions, but it's just something that I wouldn't necessarily recommend you do. So when you fetch data with SwiftUI, you use a property wrapper called fetch request. And that fetch request has multiple initializers. The one on the slide is my least favorite one. That's one where you pass an entity and sort descriptors to specify how your data should be sorted. You can also create a fetch request that encapsulate all of this external to this fetch request property wrapper and pass that. But I wanted to show you this just so you know sort of what goes into a fetch request without needing to go into too much detail on fetch requests, because I want to talk about SwiftUI and core data more than details on core data. So, and I know that this looks like a break in encapsulation in a lot of ways, right? Because this SwiftUI view now has some kind of knowledge about the model layers and where data comes from. At the same time, maybe it doesn't. Maybe Apple's going to introduce something where the fetch request could have multiple underlying stores, and all this view knows is really that is going to show an array of speakers. But for now, it's always core data, of course. So if you would want to abstract this, you're most likely going to end up re-implementing what this thing already does for you anyway. And the closest thing that I have built that I liked was something that looked a bit like this. So I had a view model that's an observable object, and it's a wrapper around a fetch results controller, which is the object that we used in the past to fetch data from core data and observe changes to the fetch data and update everything. And basically, it was perfect for driving things like table views or collection views. And it does this by notifying its delegate. And in this pairing, you would basically do what fetch request already does for you. So doing this, I don't know if that is the best idea. You could do it, and it would look a little bit like this. Right. And again, I don't know if this is the best idea, because there's a few things that I sacrifice here. And one of them is I read all of the objects from my fetch results controller at once. And what that means is that core data is going to load all of my objects into memory. And normally it would not do this. It would try to postpone actually loading an object into memory for as long as possible. So when doing this, you basically throw a lot of optimization out the window. And that could be fine for very small data sets, but for larger data sets, it could be a problem. And more importantly, this doesn't support sections. So that could be a problem too. An alternative to this is something like this, right? It looks very similar in terms of how much code is on the slide, but what I'm doing here is I iterate over the number of sections, for example. So I would go in my SwiftUI view, I'd make a list over a range of 0 to number of sections. And that could create sections for me. That would be very nice. And I could also iterate over 0 through numbers of items in section, which, would get me all of the views all of the items per section. But this would look very weird in SwiftUI, and I wouldn't be a fan of this. What is nice is that we would trigger an update in the view simply by sending the object will change publisher, and that works nicely, but I don't know. I'm not a fan of this, and I think fetch request can do the work for us, so we should use it for that and just let it do what it does best. One of the less obvious things that Apple did for core data and SwiftUI integration that I absolutely love is that, use the fetch request. So when we manipulate records, and one of the things that I absolutely love is that Apple made managed object an observable object. So that means that when we have a managed object in our view, we can actually bind our UI directly to it, and the managed object will update, the UI will update, and everything will be as magical as it is with a normal observable or state object, of course. And what's also very nice is that all of the NS managed properties are considered published. You cannot subscribe to them yourself. You can observe them using key path observing. But whenever a managed property changes, so whenever one of these properties that you know is in your model changes, Core Data will automatically update your SwiftUI view. So Apple definitely did think of a lot of integrations with SwiftUI for Core Data, and this makes it very seamless. So let's look at a little bit of code. And let's assume that I have a list view and I have an add button somewhere in my UI. I tap the add button and I present a new instance of edit speaker view. This would create a new speaker. And the way I like to create this is by creating a speaker view and passing it a view model. I'm a big fan of the MVVM architecture because it's kind of lightweight in my opinion, and it sort of allows for a lot of free form of where you put things. So I pass my persistence controller to this edit view model. It has to be available, of course, in the parent view, and we can do that through dependency injection or through the environment if we prefer to do that. So let's look at what happens inside of my edit view model. And note that I am making an edit view model and I'm talking about creating a new speaker. And that's on purpose because I'm going to show you how you can use one view for both edit and add operations. Okay, so we have our struct edit view model, and we have an initializer that takes a persistence controller and an optional speaker. We can pass a speaker if we want to edit a speaker. We pass nil if we want to create a new speaker. So the first thing I do here is I obtain a child context. And this child context will provide us with a new managed object context that we can use for our isolated changes. So I'm going to talk about child context a little bit more, but this allows us to isolate changes from the UI or from the main UI. Next thing is I create a new instance of my speaker. I do this by calling persistence controller new temporary instance in context. I'll show you the implementation for this function in a moment. It's just a little generic function that would allow me to do some common setup for a specific managed object. Now, if I would edit a speaker, I would, like I mentioned, pass this speaker to my edit view model initializer. So when this is called, we go back to the edit view model, and you can see that if let speaker equals speaker, I obtain a copy for editing of speaker in context. I'm going to show you the code for this in a moment. I just want to sort of go and drill down level by level. So what's interesting to keep in mind here is that I associate this existing speaker, or I obtain a copy of this existing speaker, and I associate that with this child context. So you can already tell that I'm loading a copy based on that. Okay, so let's take a look at the edit speaker view before we go deeper into contexts. The edit speaker view here looks pretty plain and pretty not core data, and that's beautiful. That's what I like. And this state property here, that's a view model, and we can just bind to that speaker here, you see? View model speaker name for the text field. Now, because Xcode would generate a speaker with name being an optional string by default, you can add a little helper that converts a binding from string optional to binding string. I didn't put the helper in the presentation because there's plenty of examples on the internet, but I just wanted to mention it that it's something custom and not something built in. And whenever we're ready with our edits, we can just say view model.persist and the speaker object will be persisted. So that's pretty neat. And this I think is much nicer isolated than the fetch request example, because this to me looks like it could use anything as a backend. And that's what we were going for, I guess. So what are the takeaways for this part where I showed you how to edit or add new objects? Managed objects are observable objects, and that's super convenient. That's very useful to sort of hide core data from our views. And managed properties, annotated by n as managed, are treated as if they are published. And most importantly, because of this convenient way that things are structured, you can use the same view for editing and creating a new record in SwiftUI. So enough about sort of the edit and create part. Let's talk about multiple managed object contexts because they are super important in what I just showed you, and you'll understand why after this section of the talk. Before I show you that, let's go over Chordata's threading rules. Because managed objects, as I already mentioned in the beginning, cannot be passed between threads. If you load a managed object into the view context, it has to be used on the main queue. Managed objects should also only be accessed on their context queue. So even if you have two background contexts and you assume that they're on the same queue, make sure that you run your code on the correct queue. And you can do this by calling perform or perform and wait on a managed object context. The view context is the queue that runs on the main queue, and this is the only context that you should use to fetch objects for your UI. In the example just now, I created a child context, and that's a child of the view context, so that also runs on the main queue. You'll see how I did that in a moment. And again, call perform or perform and wait on your managed object context to run code on its queue. This is the only way to make sure that if you are on any thread, that your code runs on the correct thread for that specific managed object context, and it allows you to safely interact with managed object loaded into that queue. Now, this is all very good, but it's often hard to debug this, or it's even hard to get this to crash, because if you have code on different queues and they run on the same thread, Chordata might not have problems with that. And of course, Chordata sort of starts doing weird stuff as soon as you ship your app and it's in users' hands. And then suddenly every queue is a different thread and your app crashes and you're not sure why. To help you debug this, or at least to help you even prevent this completely, you can use a nice debug schema argument. That's com.apple.chordata.concurrency_debug1. If you pass this to your app while debugging, Chordata will be very strict on how it asserts its threading rules. And so as soon as you make a mistake, it will crash your app. So this will make sure that you always use perform and wait in the right places when needed. Okay, so this is good. This is the threading rules. Let's look at the code that I've been telling you about, which is the code that I used in the edit view model to obtain a child context and a temporary instance. So this here is would exist in our persistence controller. And this function is called by the view model to obtain a child context. And the way I create a child context is I create a new instance of NS managed object context, and I can pass that a concurrency type. You can either pass it a main concurrency type or a private concurrency type, where main would make sure that this context is associated to the main queue. If you choose private concurrency, then it runs on some internal queue to Chordata. You cannot see it. It's also known as a background context. As soon as you set a context parent, so in this case I'm setting it to my view context, this will copy the concurrency type of its parent. So even if I would have chosen private here, I would still end up with a context that runs on the main queue as a child of the view context. And my new temporary instance is really very simple. Like I said, it's mostly so I could add more if I wanted to. In this case, I wanted to keep it simple. So it just returns an instance of generic T and associates the new instance of this new managed object with the context that it was given, in this case, a child context. So the reason this child context is so important is because normally when you load data in a SwiftUI app, the flow of it looks a little bit like this. You have your SwiftUI list, you have your fetch request, you have your view context. And the view context feeds into the fetch request, and the fetch request feeds your list. And if you have 3 speakers in your view context, all 3 speakers are shown to the user. If you add a speaker, then 4 speakers exist in the view context, and automatically this view context will tell the fetch request, or the fetch request will detect this, and the fetch request will then update your SwiftUI list. Now, if this would happen inside of your edit view and you discard the edit view without explicitly removing this speaker right here, it would remain in your context. So it would remain in your SwiftUI list, even though you didn't want to persist it, for the sole reason that it's associated to your view context. So you could either opt to remove it yourself, or we could take a different approach. And that approach is to create a child context. And if we create a child context and add our speaker to that, you can see that this child context is not associated with our view context at all. So that means that it doesn't trickle down to our list, and this speaker now exists purely as long as this child context is around. If we would cancel our edit, the child context is discarded and we're all good. If we decide to save, however, this child context will be saved into the view context and in turn update the fetch request and in turn update the SwiftUI list. And again, discarding this will make sure that the context and all changes made within it are gone. So even if you would go for editing a speaker, if you would load a speaker into the child context, if it's a copy of a speaker that's currently in the view context, those changes are isolated. So as soon as you discard the child context and that instance of your speaker, the original instance will not be modified. Now, because I told you that the child context saves to the view context, that means it's not persisted automatically. To persist changes made in a child context, you need to save the child context to its parent and then change the parent or save the parent to the persistent store. Okay, so that sort of explains the whole setup with the child context, and I hope you understand why I mentioned that the child context is so important, because it allows us to create edit and add views that are completely separate storage-wise from our view context and completely separate from the data in our application. And with view models, we can isolate this all into their own little corners. So this persist function right here is called by the view model, right, to persist the speaker. And like I mentioned, first it saves the child context and then it saves the view context, because the view context needs to save to the persistent store. Let's also look at the copy for editing function, because that's an interesting one. It's called by the view model to obtain an editable copy of the speaker, and it loads the speaker into the child context through an object ID. And an important thing to know is that object IDs are used to uniquely identify objects, records in core data across threads. And it's the only property that you can access safely across threads. So we can use an object's object ID and then ask another context to find an object with that object ID and cast it to whatever we need. So I made this method right here generic so that I can use it for any record in my store. And of course, I consider it a fatal error to pass a non-existing object, because that would be very weird if the object that you just passed did not exist. Okay, so multiple managed object contexts. They can be tricky if you don't follow the rules all the time. They can be debugged with a launch argument, and I would highly recommend that you always use this launch argument when you can. Child contexts provide lightweight, discardable scratchpad. Creating a child context is not expensive, and you should do it if you want to isolate changes like we did in this quick example. Now, child contexts save to their parent context and not to the persistent store. So that means that you need to save two contexts if you want to persist something that you did in the child context forever. And most importantly, I hope that you understand that they are much less scary when you're not finding the framework. The more you fight the framework with abstractions, the more likely it is that you're going to run into trouble here, because it will be harder to manage everything. And speaking of fighting the framework and abstractions, I don't believe that Core Data was designed to be pushed into a corner. It has far too many affordances and far too many features for us to be shoving them away into some dark corner of your model layer. I do, however, understand that Apple's design choices might not be perfect, and I hope you understand that too. And that means that even if we are not supposed to push core data into a corner as far as possible, it might feel like you should sometimes, because not everything Apple does is perfect. We all know that. If you do decide to abstract, make sure you know what you're doing. I have seen people write abstractions around core data after one day of trying it. That's the best way to get into trouble down the line, because core data is a pretty big framework, and I wouldn't say that it's extremely complicated, but abstracting something you don't fully understand is always tough. And especially if you're going to abstract core data as if it's a SQLite wrapper, that is going to cause you trouble, because core data is not a SQLite wrapper. And as I was preparing this talk, I saw a post, and I thought it was the best one on abstracting core data so far. It's written by Dave DeLong. He works at Apple, and he knows a ton about core data, and he did some really cool work to abstract core data into SwiftUI. So that's really, really cool. So let's summarize this. I told you a lot about core data, and I hope I've shown you without going into too many code samples and details. I hope I've managed to sort of convince you that core data is not as terrible as some people make it seem, especially when you embrace core data rather than trying to push it away. Core data actually has pretty good integrations already for SwiftUI, and I can only imagine that this is going to get better and better over time. And of course, what I'm showing here might not work for your app. It might not be the absolute best thing, but I do think that before you abstract and before you try something different, it's good to understand what you already have and how you can use it in a nice way. If you like this talk and you want to learn more about core data, you want to learn more about core data and SwiftUI and more about all the features that I talked about, check out my book. It's called Practical Core Data. Um, and it has code for UIKit and SwiftUI. And with that, I would like to thank you for your attention. And let's see if there are